In its totality, this video is going to cover the heart of algebra section as they define it on the SAT. That basically includes linear functions. How do I start with points or a slope and a point and create the equation of a line? How do I graph that line? How do I interpret that line? How might I evaluate or solve that linear equation? How do I extend that to multiple lines, a system of linear equations, and solve that? Or even a system of linear inequalities and begin to solve and graph that as well, or even absolute value linear equations. That's essentially in total what we're going to cover. We begin with the Cartesian coordinate plane, where every point is defined with an x and a y coordinate on our xy axes, our Cartesian plane. We begin with the concepts of distance, midpoint, and slope. So let's jump right into it. What is distance? Well, distance we can define by our distance formula. D equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And boy, that's an ugly formula. Most of you will forget it a day later. Okay, it works, but essentially if you think about it, this is the Pythagorean theorem. If I have any 2 points on a Cartesian coordinate plane, I have an x2 minus an x1, call that B, and I've got a y2 minus y1, let's call that A. By the way, the x and y Cartesian axes are perpendicular to each other, so A and B form right angles, which means our distance is essentially the hypotenuse of a right triangle. We call it D, but in Pythagorean's theorem, we might refer to it as C. A squared plus B squared equals C squared for the right triangle. Suppose my first point here was something like 5, 4. And then my next point over here would be 1, 1. What do I know? I know the difference in y's is my y2, 4, minus my y1, which is 4 minus 1, or 3. That's one leg of my right triangle, A equals 3. The difference in x's, 5, x2, minus x1, which is 1 here, is a distance of 4. My b, the other leg of my right triangle in this case, is 4. My Pythagorean theorem simply works out to a squared plus b squared equals c squared. So what do I get? I get 3 squared plus 4 squared equals some distance, we'll call that c, my hypotenuse of the right triangle squared. Well, c equals the square root of 9 plus 16. That's 3 squared plus 4 squared. C equals the square root of 25, which is simply 5. Okay. One thing to note is that your Pythagorean triples, which are most commonly known as your 3, 4, 5, and 5, 12, 13 triple. There are infinitely many of them, 8, 15, 17. I can go on and on and on. But these are the two you really want to know for the exam. If I see any ratio or scaled proportion of 3, 4, 5, for example, and I'm given 2 of the legs, I can calculate the distance between those points. If I have 3 and 4, I immediately know that distance between them is 5. Or if it were 6 and 8, I know the distance between them is 10. And same thing for the other triples, which help us very quickly, without a calculator, calculate some distances for the exam. Next concept, midpoint. Well, we know on a number line, the midpoint is the point exactly between 2 points. Mathematically, we calculate that as the average of the 2 points. Well, all a Cartesian coordinate system is 2 number lines, one vertical, one horizontal. And if we want to find the midpoint, that is the x and separately the y coordinates that are the midpoints, well, we do it the same way. We just calculate the average for the x's and the average for the y's. Well, how does that work? Let's go back to our original 2 points here. I want the midpoint right there. What is that going to be? Well, that's going to be x1 plus x2 over 2, the average of the x's, which in this case is 5 plus 1 over 2. Comma, y coordinate. Don't forget, your midpoint is an xy coordinate. It's not 5 or 10 or some linear scaled amount. let's look at the average of the y's. The y's is 4 plus 1, and we're dividing by 2 because there are 2 of them in the average. That means our midpoint is essentially going to be 5 plus 1, 6 over 2 is 3, comma, 4 plus 1, 5 over 2. That is the point that's exactly in between the 2 points given in our triangle, on our hypotenuse. Exact. Okay, what about slope? How exactly do we calculate and interpret slope? What is slope? This becomes a very important concept in linear functions and equations. We typically define slope for a line as a constant, m. And the reason it's constant because a slope, unlike any curvy line, doesn't change. Notice at this point, I've got a rise over a run, which is our slope generally. That's very different, say, at this point, where our rise over a run is here, and here it might be very different indeed as well, right? But a line always has that same rise over the run. It's essentially, I have a line, and my change in y, that is my y2 minus y1. I'll use the delta symbol, not a triangle. It means the Greek letter delta, which means change. Delta y divided by the horizontal change, the delta x. That's how we calculate our slope. Okay, so let's see that in action. What would the slope be for the 2 points shown up above, 5, 4, and 1, 1? Well, in this case, it's going to be y2 minus y1, 4 minus 1 divided by x2 minus x1, which is 5 minus 1, and that slope then becomes 3/4. So the correct slope for the example shown above between the points 1, 1 and 5, 4 is 3/4. Note that's a positive slope, and it's a very important concept, whether that slope is positive, negative, 0, or undefined. Let's look at a few examples of that for a couple seconds. If my line is up to the right, as shown here, it's a positive slope. So up to the right is positive. Down to the right is a negative slope. Horizontal slope equals 0. Think about it. Your change in y on a horizontal line is 0. That point and that point and that point on a horizontal line all have the same y. So y2 minus y1 is always 0. Well, what about if my line's vertical, on the other hand? What do we do in that case? Suppose my line goes directly up and down. At that point, the x values are the same for every line, and my change in x is 0. But that's a problem, because that means I'm dividing by 0. My delta y over delta x becomes some number, call it n, divided by 0, which, as you might know, is undefined. We can't divide by 0. It doesn't make sense. So what do we do in that case? Well, we still have an equation for the line. It's just x equals whatever the value is, but the slope is undefined. Now, what happens if my slope is positive and it becomes a little flatter? What does that do to the magnitude of the slope? Well, it becomes smaller, closer and closer to our horizontal m equals 0 slope. It might become fractional, a 1/2 slope, for example. And what happens, or what makes my slope very steep? Well, that m value gets much bigger. It might become 3, 4, 5, 10. And those slopes would therefore look a lot steeper than the original one shown. So it's good to get a sense of the slope, what positive, negative, horizontal 0 slope is, and how it changes the line or the graph as the magnitude of slope changes.